Assalamu alaikum wa rahmatullah. Good day, everyone, and I welcome you all as usual to our physics class. And today we will solve problem on electric potential. The second problem, actually, problem 2 says find the work done in moving a charge, and the charge Q has the magnitude 3 millicoulomb from point B at a potential V sub B is equal to 500 volt, meaning the electric potential, this charge is at point B, and at that point B the electric potential at point B is 500 volt. Now you are taking the charge from this point B to a point a second point A, all in the electric field. Okay, everything here is happening in an electric field, don't forget that, to a point A, and at a potential V sub A equals 400 volts. You can see that the potential at A is greater than the potential at B, and you are taking this charge from point B at low potential to point A at high potential. And all these potentials, V sub B and V sub A, the 500 volt and the 700 volt, are taken with respect to a certain point C, because this point is where the charge is. The 500 volt and the 700 volts at those points are the electric potentials due to the charge at point C. Okay, this one is just a test charge. Okay, after finding the work done, the question is we should find the work done in joules. Work done in joules for taking this charge from point A to point B. If you take it from point B to point A, a certain amount of work must be done to do that. So what is the work done in joules? Now, the next question is the work done by the field or against the field? Because in an electric field, one of two is happening, one of these two. If a work is done in an electric field, the work is either done by the field itself, meaning the forces of the field did the work. That's the meaning. The forces of the field did the work. Or the work is done against, the work is done against the field. Against the field meaning you needed an external force to do the work, not the force of the field, not the Coulomb force did the work, but force from outside the system did the work, such as you have somebody pushing the charges. The force applied by that person clearly is not a force of the system, it's an external force. So when this happens, we say work is done against the field. If the field, the force of the field did the work, then work is done by the field. So here, what they are telling us is, after finding the work, let us give our decision from the result. Is this work done by the field or against the field? Okay, that was background information about our problem 2 before we start solving. Of course, we have to understand the problem very well. You can see that the problem has to do with electric potential. Okay, electric potential difference. Now, what is the, since they say work done, what is the formula for calculating work done, okay, in an electric field? And that has to relate to the electric potential, meaning find a formula that combines electric potential and work done together. Okay, remember the definition of electric potential. They said electric potential is the work done in moving a unit positive charge from infinity to that point. Okay, you have a charge. Okay, you move that charge from infinity to that point. So the formula for electric potential solution, electric potential is V. Remember, V is for electric potential is equal to the work done, and you see, divided by the charge. This is the formula. Okay, electric potential is equal to work done in moving the charge divided by the charge itself. Okay, since you have you are not dealing with charge at infinity, okay, you have just 2 points. You have 2 points. Let's say this is my point A and this is my point B. The electric potential at point A, they said, is 700 volt, and the electric potential at point B is 500 volt. My charge Q is here. I have my charge Q is here. I am taking this charge from here to here. So it means the potential I will be using, since I have two different potentials here, the potential I will be using here is potential difference, AB, the difference in potentials between these two. And then this W becomes the work done in moving my charge from here to here. See that? The work done in moving my charge from here to here. Great. Wow. Remember also they say that with respect to a certain point C, so let's say this is where we have the point C. At this point C, we have the charge that generates the electric field. Okay? So this potential is due to this charge. The second potential also is due to this charge. You see, A has to be closer because A has higher potential, and the closer you get to the charge, the more potential you're gonna have. Okay, good. So this means here I will just take the difference between these two, and then my Q is the charge here and my charge is this. So I will make W the subject of the formula. This implies that my W equals, that's the work done, Q times this. So I will have Q V sub AB, and this is equal to Q into V sub A minus V sub B. You know, it is taken from where? From B to A. So B is final, A is final, B is initial. So we take final minus initial, V sub A, V sub B. This is our V sub A, V sub A, and this is our V sub B, right? So now we make the substitution. If we make the substitution, our Q has this value, but this merely means times 10 to the power of minus 3. Don't forget that, minus 3. So I have 3 times 10 to the power of minus 3. Then I open bracket V sub A. My V sub A is 700. So I have 700 here minus V sub B. My V sub B is 500. So I have 500 here. I close the bracket. Next, I bring my calculator. Okay, let me bring it closer. Okay, so you have here 3 exponential minus 3. So you press that 3 exponential negative 3. Then you open bracket and say 700 minus 500. See, close bracket. After closing the bracket, press the equality function. When you press that, what do you have? 0.6, right? 0.6. So this is equal to 0.6. Now, the work done is measured in joules. So you put joules here. The work done, this means that the work done in moving this charge from B to A is 0.6. we have answered the first part of the problem. Now, how do we answer the last part of the problem? Is the work done by the field or against the field? Okay, here is the idea you should consider. My charge here that generates the field is a positive charge. My charge here, that is my test charge here that I am bringing from here to here, is also a positive charge. Okay, what will the field do? The force of the field, let's say we don't have external forces only, then the force of the field is a Coulomb force, and we see that since they are like charges, both positive, this charge here will repel this one. There is no way the force of the field will bring your charge from B to A, okay, at all, because the direction of the Coulomb force is here. So the work is not done by the field. You need an external force to do the work. You need an external force to push this charge against the Coulomb force that is trying to pull it in this direction to bring it to A. So clearly work is done against the field. Against the field. Okay, another idea is to look at the result. If the result here is positive, it means the work is done against the field. If the result is negative, then the work is done by the field. And clearly our result is positive. So work is done against the field. Okay? Because final minus initial should give you a positive value, right? If final minus initial gives you a negative value, it means work is done against, so the work is done by the field. Because if it is by the field, let's say my charge is initially here. This is where I have my charge here, and I am taking this charge from here to here. I don't need external force, because the Coulomb force will push the force between these two, okay, will push or pull my charge from point A to point B. There is no need for an external force to do that. You see that? So when it does that, from this point to this point, the potential difference should be final minus initial, 500 minus 700. 500 minus 700 will give us negative 200. From there you can see that we will have a negative result here if the work is done by the field. So in summary, class, work is done, since the result is positive, work is done against the field. Against the field. Work is done against the field. Finally, in summary, class, our results are 2. First of all, the work done is 0.6 joule, and this work done is done against the field because it is a positive work done. Thank you all for watching.